This video is over section 6.3, average rate of change, difference quotient, and function behavior. This is pretty vocabulary heavy, so bear with me at the beginning. Pretty easy in application though. So average rate of change of a function says that suppose that points x1, y1, and x2, y2 are points on the graph of a function f. Using function notation, these points are x1, f of x1, and x2, f of x2. So I'll just use colors just so you can see it, but x1, y1 is the same thing as f of, x1, f of x1. So like these are interchangeable here. When you're using function notation, you use the bottom one. And same thing here, x2, y2 is the same thing as x2, f of x2. If f is defined on the interval x1 to x2, then the average rate of change of f on the interval x1 to x2 is the slope of the secant line containing x1 f of x1, x2 f of x2. So it maybe has been a minute since you talked about what a secant line is, but if you look at this picture here, I'll zoom in, it's a little blurry, but this pink line is the secant line. It takes 2 points on the curve and connects them with a straight line. And how we get the slope is we use our slope formula. This is modified a little bit because of using function notation, but basically we're taking the change in the y's divided by the changes in the x. That's seen over here. Slope is the change in y over the change in x. So you can use the points y2 minus y1, or over here function notation, same thing, f of x2 minus f of x1. Okay, so let's look at a couple problems dealing with this. So it says let the x-axis represent time in minutes after 9:30 p.m. So this would be time in minutes, okay, and then let the y-axis represent the number of stars. So I'm just going to put a star visible in the night sky. Determine the average rate of change, of number of stars visible in the sky on a given night. So A is from x1 equals 0 to x2 equals 40. So the average rate of change, we're going to use m, and we're going to do y2 minus y1. You could do f of x2 minus f of x1. Sorry, I just didn't want to write as much. So y is just shorter, but technically it is a function, so you would do f of x. And then on the denominator, we have x2 minus x1. So when I plug in the denominator, it's pretty self-explanatory from the problem. We're going to be doing 40 minus 0. And to get the numerator, we need to see, okay, what is y2 and what is y1? So I'm going to write that here. But then, yeah, we're going to go to our graph and see what that is. So when x is 0, that would be this dot here. I guess let me use color so we can see a little bit better. I'll use pink for this one. So when I put a dot here, the y value is about 600. So I'm going to make this value here 600. And then I'll use orange for this one. When my x is 40, my y value is about 200. So I'm going to put 200 here. And now I can plug in 600, 200 into my formula. y2 minus y1, and then I can reduce. So this would give me negative 400 over 40, which would be negative 10. I'm second guessing myself for a second. Okay, part B says from x1 equals 40 to x2 equals 80. So we already used x1 equals 40. It was our x2 above, so I'm just going to write here y1 is equal to 200. We already used that dot there. And then let's use green for this dot. And so when I think about x2 being 80, that would be here, my green dot, and that is at 800. So when I go back over here, I'm going to have y2 is equal to, and we decided that was at about 800. Okay, so when I do my average rate of change, I'm doing m equals y2 minus y1 all over x2 minus x1. And when I plug in what I found by looking at the graph, I'm going to have 800 minus 200 divided by 80 minus 40. And so I'm going to get 600 over 40. And when I do that, I'm going to get 15, positive. And then part C says interpret the results from part A and part B. So for part A, negative 10 means that for every minute increase, the star visibility decreases by 10 stars on average between 0 and 40 minutes after 9:30 p.m. So the keywords here would be decreases and then by 10 stars and then on average between 0 and 40. So those are kind of like the buzzwords there. I am lazy and I'm just going to copy this and paste it. Oops, I don't want to paste it as an image. So I don't have to rewrite all that. Copy and paste it right below. If I can get it. I lost it. Hold on. That'd be quicker. Hold on. Okay, great. So I'm going to erase a few things. So the other, why my eraser's not working? Okay, so for every minute increase, the star visibility decreases. So we need to change that because for our second number, we have 15 by, and then 10 is not the right number anymore either. On average between 0 and 40 minutes. And then we're not looking between 0 and 40 either. So I'm going to erase the 0 and I'm going to erase the 40. Okay, so now when we're thinking about part B, it's 15. For every minute increase, the star visibility increases, because 15 is positive, by 15 stars on average between, this one goes from 40 to 80 minutes. All right, this next section says, given the function defined by f of x equals 2x cubed minus 3x, determine the average rate of change from x1 equals 3 to x2 equals 0. So the slope formula, or the average rate of change, will be found by f of x2 minus f of x1 over x2 minus x1. So before we start, I think finding f of x2 and f of x1 is probably wise so we don't mess up down the line. So I'm going to grab a color here. So f of x2 is f of 0. And when I plug in 0, that's going to be 2 times 0 cubed minus 3 times 0. And that's just going to give me 0. When I do f of x1, that's going to be f of negative 3. So I'm pulling that from here. And that's going to be 2 times negative 3 cubed minus 3 times negative 3. And I'm going to use my calculator so I don't mess up my mental math. And when I do that, I get negative 45. Okay, so again, I got 0 for x2 because of the problem. All right, so let's plug in what we know. F of x2 we got was 0 minus f of x1 we got negative 45. So notice there's two negatives here. And then problem, we were given x2 and x1, so this would be 0 minus negative 3. So this is really 45 over 3, or just 15. Most of this can be done in your calculator. I wrote it all out. I'd probably do that all in my calculator. All right, next section, intervals of increasing, decreasing, and constant behavior. Suppose that I is an interval contained within the domain of a function f. F is increasing, so let's use a color pink. F is increasing on I if f of x1 is less than f of x2 for all x1 less than x2. Okay, so basically means so the further that you go to the right, the bigger the y values. So if you look at the picture, that first graph is increasing because left to right, the graph is going up. Next, f is decreasing on I if f of x1 is greater than f of x of 2 for all x1 less than x2. So the second one is decreasing because left to right, the graph is going down. And then the last one says f is constant if on I if f of x1 is equal to f of x2 for all x1 less than x2. So this last one is constant, not changing left to right. All right, this says use interval notation to write the intervals over which f is, and then increasing, decreasing, and constant. So I'm going to use that same color code. Increasing, I'm going to use red, pink. Decreasing, I'm going to use green. And then constant, I will use yellow. Okay, so this first section of the graph starts here and goes to here. And that left to right, that graph is going down. So that first section is decreasing. Okay, the next section starts here and goes to here. Well, actually, let's just go ahead and write it out. So in the decreasing section, those are all, we're going to consider them to be filled in dots. So it is decreasing from x equals 0 to x equals 1. Okay, and so that's how we write it. So this is from x equals 0 to x equals 1. So you wouldn't actually write that bottom part. I should have written it in orange, but what that means is 0 to 1, the graph is decreasing. All right, the next section of our graph goes from that point to 2, and that is a constant section. So I'm going to highlight that in yellow. Okay, and I'm going to add that to our constant part C. So that means from x equals 1 to x equals 2, the graph is constant. And we're using interval notation here. All right, the next section of our graph goes to, there's a bump in the graph here, but notice from this dot to this dot, the graph is increasing, but it continues to increase to the next dot as well. So we can combine those two intervals and go all the way from x equals 2 to x equals 4 on that one. So for increasing, we have x equals 2, all the way to x equals 4 is increasing. All right, and then our last section of our graph is from that last dot until here, and I'm kind of rounding, that's not perfect, just a graph I found off Google, but this last section is decreasing. So we're going down for that last section, and when we combine, when we're looking at multiple intervals, we're going to use this U or union symbol. Oops, I put that in the wrong spot. Decreasing union, we're going down starting at x equals 4 and then stopping at x equals 6. And we don't include any endpoints with the square brackets when we're doing just intervals. All right, last thing we'll talk about is relative minimum and relative maximum values. So f of a is a relative maximum. Again, I'm going to pull a color. Excuse me. Relative maximum of f if there exists an open interval containing a such that f of a is greater than or equal to f of x for all the x in that interval. And then f of b is a relative minimum value of f if there exists an open interval containing b such that f of b is less than or equal to f of x for all x in that interval. And then note an open interval is just an interval with endpoints not included. Okay, if an ordered pair A and f of A corresponds to a relative minimum or a relative maximum, we interpret the coordinates of the ordered pair as follows. The x-coordinate is the location, so I'm going to underline that, of the relative maximum or minimum with the domain and the function. The y-coordinate is the value of the relative maximum or minimum. This tells us how high or low the graph is at that point. A lot of words, but it's really not hard. So if I'm looking at this graph, part A says determine the location and value of any relative maxima, and then part B says determine location and value of any relative minima. So if I'm looking at this graph, and note it, like you can't use the endpoints either, is what it's saying. So I'm not going to use that or that. So the first point that I see that is like a turning point would be here. And if we notice, both on the left and the right, the line, that red line is above that blue point that I put. And so since it's above the blue point that I put, that point right here is a minimum. What color did I use? I used pink for that. So this is a minimum value, okay? And so how I will write this, because it says determine the location of the value. So this graph, I'm going to write g of x has a relative minimum of, and that value is the y value of -1, and the location, so at, is x equals -2. So the minimum value is that y value, so -1, and then the location is where it is in the domain, so where it is on the x. Oops. Okay, so the next point that we come across would be this dot right here. And notice that is an upper point, so it's on the top of both points on the sides of it. And so that is going to be a relative maxima. Okay, so g of x has a relative maxima of, and the maximum value is the y value, so 3 would be the maximum value, and the location, so at, would be the number in the domain, or the x value, x equals 1. Okay, the next point that we come across is this point right here. That is a minimum because it's on the bottom. And just a shorthand, I'm going to just write that minimum value of -4, and that's at x is equal to +2. All right, the next turning point looks like something's happening here, but you see it's increasing and increasing, so that would be nothing for the purpose of this. There's something going on here, but again, increasing to increasing, nothing for the purpose of this. However, here we have increasing to decreasing, and so that is a relative maximum. Excuse me. So that is a maximum of 8, and the location is at x equals 6. And that is the last point that we have. So let me go ahead and highlight so we can kind of see. We have a maximum. Oops, I think I changed my color, didn't I? Yeah, maximum, I used green. So we have maximums here and here, and then we have minimums here and here. And note that it didn't want us to use the endpoints because it says endpoints are not included.